So, hello everyone. My name is Sanditya Larope Sutanto from Universitas Indonesia. So now I will explain to you about a brief introduction into wireless communication. So let's start with the definition itself. What is wireless communication? So from here, it is stated that wireless communication is a type of data communication that is performed and delivered wirelessly, so without wire. And actually, wireless communication is a broad term that incorporates all procedures and forms of connecting and communicating between two or more devices using a wireless signal through wireless communication technologies and devices. Then let's see the prospect of wireless communication. Uh, there are actually many prospects, but the one that I will talk to you here is about Internet of Things. So this technology, Internet of Things, is one of the future of wireless communication. So let's see, what is actually Internet of Things? So in my definition, I define Internet of Things as a technology that allows not only smart objects like smartphones or laptops, but actually quote unquote stupid objects such as your desk or your plant system, your plant's watering system, or maybe your door or your garage that is not cannot be classified as smart objects, but with IoT, those objects can be connected to the internet and they can receive or transfer data uh, to be monitored or to be controlled. Okay, so there are actually three main aspects of IoT. So first, there is monitoring, and there's controlling, and there is insights. So the first step is monitoring. So from the device, for example, there are many sensors that transfer data to a dashboard or to us, to humans, so we can monitor it. And then from the data, we can we can perform actions. So this is actually in a embedded system. This is the part of motor or actuator. So it receives command from us humans to the to the IoT object. And then the last part is insights. So what is insights? Insights is from all the system, from this monitoring, controlling, we can gain that data and we can store it in the cloud, and we can get a deeper analysis or deeper data processing to improve our system in the long run. Okay, of course, with new technology, there might be many challenges. So let's talk about the challenges that came in terms of the network implementation. Okay, the first one is that data rate. So in this today's world, we need to make like gigabit per seconds data rates, and it should be with no errors. Why no errors? Of course, like many users nowadays, they want fewer error percentages because people enjoy high definition video and without lags or without errors. And higher quality video, of course, mean higher data rate. And the second one is energy efficiency. Energy efficiency. Nowadays, with this future network, with this future wireless communication technologies, users or one person can actually use like many telecommunication devices, like maybe their laptops or their phones or maybe their IoT objects. Who knows? And then, of course, all of this technology, they need to be powered by electricity, and electricity needs a resource to be produced. That's why there are challenges in energy on how we consume energy and how to produce it. So the device, it can be said that the device needs to be more efficient battery wise. And then the scarcity of spectrum. The spectrum wave used for wireless communication is limited. In each telecommunication technology, it is designed for a dedicated spectrum. For example, 2G works in 900 megahertz and 5G works in 3.3 to 3.8 gigahertz. So there are different spectrum, which makes it scarce. And the fourth one is reliability and coverage. Reliability, what is reliability? Reliability refers to the ability of the system in providing good service. For example, user must be provided good service from the provider. So that includes higher data rates, low latency, and overall good customer service. And coverage refers to somehow the network technology should provide a wider area, the network must be delivered to many places, not only in in large cities, yes, cities, sorry. Okay, and then sorry, this is actually devices challenges. So there are also challenges that comes in terms of the devices. First of all, performance, of course, performance. With many devices, with high level network technology, we need good performance in our phones or in our internet devices. And then the complexity, of course, nowadays in smartphones, it is more complex, and the size is getting smaller. Many complex operations are put into a small devices like our smartphones. And then size, power, cost, and energy. Of course, there are challenges in size, also in power and energy, as discussed before, and of course the cost of facilitating all of this. And then another challenge is how can we provide high frequencies or millimeter waves. People want to get high data rate, and of course it can only be provided by high frequency. And then to achieve high frequency, we need to configure multiple antennas. And then multi-radio integration refers to multi-work frequencies. For example, our smartphone, it can be used for radio, Wi-Fi, GPS, and etc. The last one is coexistence. For example, let's take an example for in our smartphone again. Our smartphone nowadays still needs to have coexistence with other technology. Like, even though it is a 4G based network, it should be able to use 2G and 3G networks also. Okay, so when there are challenges, we must have solutions, of course. So the first solution to the problems that we encounter in future wireless communication is the software-defined radio system. So this technology makes radio can be seen as software, and the digital signal processor here can be programmed so that it can be used for any technology, not only 3G, but 4G, but 5G, etc. With this technology, what can we achieve? We can achieve a high spectrum bandwidth of the signal. Okay, let's see. Another tools that we can use is the Shannon limit. So what is actually a Shannon limit? Shannon limit can be defined as something that as people develop these networks needs to know, because it can determine the upper boundaries or the capabilities of the system. So it can be said that the Shannon limit represents our network capacity. Okay, we can see here the formula. The B is bandwidth, the S is transmission power, and the noise is N here. And S per N is actually signal to noise ratio. So from this formula, we can see that if high power is used, it allows us to send or receive more information and vice versa. Okay, that's all for this video. I hope I can give a good explanation about an introduction to wireless communication. Thank you, everyone. Hope you enjoy it. Please consider dropping a like or comment below. Thank you.